All right, in this example, we've got a snowball that's melting, and its radius is given by this function r of t. And it looks like it's a linear function. So to me, this function 50 minus 2.5t is saying that the radius is initially 50 centimeters. Right, because t is in centimeter, or r is in centimeters, and it's going down by 2.5 centimeters every hour because t is in hours. All right, so we have a function for the radius of the snowball, and we also know that the snowball is spherical, and so the volume of the snowball is given by 4/3 pi r cubed. All right, so we have a function for volume in terms of radius, and we're asked to find a function for the volume in terms of t. All right, so we have a function for our volume in terms of radius, right? But our radius is a function of time. So I can put that in to the input of for the volume function. Okay, so I can, wherever I see the radius in the function for volume, I can replace it with this function for the radius in terms of time, and then I'll have a function for the volume in terms of time. So I know the volume is 4/3 pi r cubed. All right, now I'm going to put that in parentheses, but I'm going to replace, right, so it's r cubed, whatever r is, but I'm going to replace it with this function for r. And so that's 50 minus 2.5t. Okay? That's all there is to it. I'm just replacing r with the function for r, and now I have a function for the volume in terms of time. So that's called a composition of functions, and that's what one of the things we're going to be talking about today is composition functions, or composite functions. And essentially what we're doing is we're replacing the input of one function with another function instead of just a single variable. All right, so a composite function is defined by using the output of one function as the input to the other function. So we're putting, in this case, if we have f of g of x, so that's how we read this, is f of g of x. We're taking the function for the function f and replacing its input with another function. All right, so wherever we see x in the function f of x, we're replacing it with g of x instead of just x. That's all there is to it. So I'll meet you in the next video for more examples.